In the previous video, we looked at installing the 88 SiO2J card into the back plane and determined it seemed to be working. I've now got it hooked up via RS-232 via this kind of kludge here of adapters to a laptop with TerraTerm connected, and let's go ahead and see if we can get a command prompt. So it starts at address F800. Let's go ahead and examine that and run, and we get a prompt in the terminal, which is perfect. That's exactly what we expected to see. Communications are set to 9600 baud on both sides. In the previous video, we strapped the serial card to 9600. So let's look at some of the commands that the monitor gives us. So we can copy in memory, we can dump memory. So let's go ahead and dump some memory. Let's dump F800 and FF bytes. And there's the first part of the monitor. We can see down towards the bottom of the text dump there where it says by AMON 2.4 by M Ebhard. So we can see some of the messages in it. So we can look at RAM. We can enter data into memory. So let's do an enter at address 0000 C3 0700. So there's address 0123 4 5 6. This should be address 7, and we'll do a C3 back to 0000. Oh, huh. Okay, that worked different than I thought. We're going to enter a C3 to address 0700. Get up to address 7. And we're going to enter here a C3 back to address 0000. And if we now do a dump 0000 09 bytes, we should see our coded memory. Actually, should have dumped one more byte. And if we now come back around to the system and go ahead and stop and reset and examine addresses 0, we've got our C370. There's address 7 with the C30000, and I should be able to then get my address set back to 0 and run. And we're in that little jump loop that I've demonstrated a couple of times here. So let's go ahead and stop that. Let's set our start address to F8, get that loaded, and start running there again, and we get the prompt back from the monitor. So that works. That's very nice. Calls, we don't want to actually... Well, we could actually do this. We can do an EX. So let's go ahead and do an EX, and that should run that little program we just entered. So let's do an EX, and we'll give it the starting address. And that should start running that code that we entered. Stop, and we can single step here, and we can see there was... So here's the jump back to 0, so there's the jump, address 00. It's down to address 00, there's the jump up to address 07. So there it is. That's very nice. If we stop here and get the monitor running again, that works. That's pretty cool. We can fill memory. We can do a fill. Oops. Is it FI? FI. We're going to fill with AA at address 100. There's a length after that. 256 bytes, FF. Now if we DU address 100, 256 bytes, we should see we stuffed it with A's. Or really 255 bytes. Should be able to then do a fill. We'll do this. We'll do a 5-5 pattern, starting at 100, and we'll actually do 256 bytes rather than 255 like I did before. And now if we dump, starting at address 100, 256 bytes, we've written the 5 5s in. So there's a way of filling memory. That's pretty cool. We can do a search. We'll start at address F800 and we'll search for Eberhard. We should find that F8 address F8CF, and that's where, again, he's got his name in the EEPROM with the monitor. We can compare a block of memory. So AD dumps memory to the transfer port, which is the other serial connection here that I don't have hooked up. Load and execute. There's a terminal mode command. IO commands, there's an input command. So the input port FF is these 8 switches here. So if we do an in from port FF, we should read an F8. We should now read an all zeros. Should read all ones. That should read an AA. And this should read a 5.5. So yeah, things are working as expected. So we're being able to read the port FF off the front panel. This, the sense switch port is there. I've really got no way to do an out port to anything that will display here at this point. I'm going to go ahead and do a stop reset, and we want to set that as the starting address and just run the monitor again, and the monitor's there. Got various boot commands here, terminal type commands. Entry points, there's a boot from Altair hard disk. Entry point, boot from Altair table. Boot from Altair floppy. I've got a floppy controller coming early in the week, and that'll really be the next thing, is going to get a floppy up and running on it. I don't have a Cramenco byte saver, so we really can't use it to program an EEPROM. So there it is. There's a quick look at AMON. It's definitely running on the machine. We can see in the terminal session, in Terraterm, that it's actually communicating, which is pretty cool. Let's just go ahead and dump all of memory. Expect this to take a while. You can see one of the fills I did. We should hit a spot here where there's no memory installed in the machine. I think we're actually already past that, I believe. Or maybe not. I think the last address with memory is 3FFF. I don't remember. So I can look at the card here if I dare do this. I can't actually read it. Yeah, 3FFF is the last actual address we have for memory in the machine. None of this memory's been initialized, so it's just got random stuff in it. Looks like it's mostly zeros, but there's the occasional single bit that's a 1 someplace. But pretty cool. My 600 baud's rather slow, but that was pretty typical. It was actually really nice if you could get that kind of speed back in the era when these machines were heavily used. I'll let this just scroll up past 3FFF, and then we'll just be reading from open bus. There'll be no memory in the machine at those addresses, so I'm not sure what it'll return. And now it's just reading what it should, and that's FF, and it's just reading, there's nothing on the bus gets pulled up. And so it's just reading ones off the bus because there's nothing there to deploy any of the bits to 0, so that's exactly what I would expect. I'm assuming there's not a way here. Oh, Control C stops the monitor. That's very nice that Control C returns control back. So the AMON monitor, pretty cool. It came with the 0828 or the 082 SIO card that I got from Martin Eberhard. Found his website, ordered the card up. I think I've said in the previous video, this card was actually a return. It had failed in the field, and he just sent them a new card, and he repaired this card and gave me a good deal on it, and I've got no problem having a repaired card. Stuff happens. That's just reality of vintage stuff and electronics. So pretty cool. We are making definite progress here. We've got a running 8080 back here. Actually, we've got our front panel. Boy, that heatsink's getting really warm. This is the CPU here. I ain't any thermal compound on that. I'm going to need to. Front panel interface. You can't probably see the SiO2 card. Let's just go ahead and slide everything out here and take a quick final look at the machine as assembled. I don't know if all that has made it into shot or not. We're in the 10 slot motherboard that we looked at in the previous video. We've got the wiring harnesses hooked up to that motherboard off my switching power supplies. 16K RAM card. The 2 SIO, it's got 2 serial I/O ports, it's got the AMON monitor on it, it's got a few other very nice features, the front panel interface, and the 8080 CPU card that we assembled, the clone card. So pretty cool. Definitely progress. I'll wrap this up here, and I'll see you in the next video. We'll talk soon.